Hello, my dear students. I welcome you to this session of Python programming. In today's session, we'll be discussing about the assignment operator and compound assignment operators and the bitwise operators. So as you know, assignment operator is used to assign values to variables. It could be a value being assigned to a single variable, or it could be multiple variables being assigned one value in one single statement. There is another category of operators known as compound assignment operators or shorthand assignment operators. It is a shorter way of writing assignment statements. So basically there are seven shorthand or compound assignment operators: percentage equal to, slash equal to, double slash equal to, star equal to, plus equal to, minus equal to, double star equal to. So percentage equal to is shorthand modulus operator. For example, if you need to write that a is equal to a percentage 5, this means that the modulus of a and 5 is calculated and is reassigned to a. It could be written in a shorter way as a percentage equal to 5, which would mean the same, that is a equal to a percentage 5. Same is there with the rest of the shorthand assignment operators or the compound assignment operators. And all of these operators are at the same level of hierarchy, and so there is no association as such among them. Let me show you the working of these operators. Say for example, if I need to assign the value 5 to a, I should write a is equal to 5. So if I now try to see the value of a, it is 5. Or it could be b equal to c equal to d equal to 55. So if I print b or I print c or I print d, they are the same. Now let us suppose I've got a variable product with the value as 20. If I need to write this, that the new value of product is equal to the old value plus 10. So now if I see the value of product, it is obviously 30. Now this statement here, product equal to product plus 10. Here I have typed this word product twice. So a shorthand way or a compound way of writing it would be product So what is the value of product now? Is 40, because here it was updated to 30. So this product plus is equal to 10 would mean the same. Product is equal to product plus 10. But here we have typed less. So that is why it is a shorthand way of writing this. Similarly, if I've got a variable a equal to 5 and I write a equal to a double star 3. Okay, so if I see the value of a, it is 125. Okay, so I could write this as a double star equal to 3. So now it would be 125 raised to power 3. Okay, so that is this big value. So that is how you can use the shorthand assignment operators. And of course, they are useful while you are writing, while you're taking bigger variable names, like in some assignments or in projects, you take meaningful bigger names. So there your work can be cut out by writing, by using these compound or shorthand assignment operators. Let us now discuss the bitwise operators. Bitwise operators, as the name suggests, they work with the individual bits. Okay, and bits, as you know, is a acronym made out of the word binary digits. Bits means binary digits. So in total, there are 6 bitwise operators: ampersand representing bitwise AND, a pipe symbol representing bitwise OR, a caret symbol indicating bitwise exclusive OR, a tilde representing bitwise NOT, two less than signs bitwise left shift, and two greater than sign bitwise right shift. We'll discuss them one by one. So I'll be taking up the examples in detail with you so that you understand these bitwise operators. So let us go to our Python interpreter, and let me start a fresh window of it so that we have a clear screen. And once we get this, we can just start working with it. For example, if I take a variable a with the value as 4. So how it is written in binary? So you can check this out with this bin function. So binary here is 1 0 0. Okay, 0b indicates that it's a binary equivalent, so 1 0 0. Okay, and this bitwise AND, if we see bitwise AND, what it does, it does a bitwise AND. Each bit of the output is 1 if the corresponding bit of X and of Y is 1. Otherwise, it's 0. So, in other sense, you've studied about gates also in your plus 1 and plus 2, the logical gates. So, AND gate is something in which the output is high if both the inputs are high. So, in a programming concept, we can say that if both the conditions are true, or if both the bits are true, here in the case of bitwise operators, both the bits are high, then the output is high. If even if one of the bits is low, then the output is 0. Okay, so let's go to Python shell. Let's say A as 4 and B as 7. So let's look for their binary equivalence. It would be 1 0 0, and for B would be 1 1 1. So here if you AND them, this 0 with this 1 results in 0, this 0 with this 1 results in 0, and this 1 and this 1 results in 1. So the output is 1 0 0. That means the output is 4. So we can check here A and B. So you can see the output is 4 here. Let's take another example. Say if A is 18 and B is say 36. Okay, so you can check their binary equivalence, and then we can see what the output would be like. So here you can see the best thing for you would be to put it in an 8-bit pattern. Okay, so like A could be represented as, I hope I'm clear here. Okay, and B could be represented as, and then you can do the ANDing of the individual bits. Okay, so let's now do this, the AND, and let's see what's the answer here. So the answer is 0. That means none of the corresponding bits, both of them were not high. Somewhere there was 0, somewhere there was 1. So none of the cases we had a 1 1 combination. Now look at this, the other operator, bitwise operator OR. Here in a OR gate or in bitwise OR, even if one of the bits is 1, the output is 1. So let's take the case of A is equal to 4 and B is equal to say 11. Let's convert them into their respective binaries. Okay, so here you see the output would be, it is 1 0, so 1 1 0 1, so 0 1 1 1. So all ones are there. So the output here would be, all ones would be 15. Okay, so I hope you understand, or how to calculate the conversions from decimal to binary and binary to decimal and decimal to hexadecimal. So if you are aware, then it's a good thing. Otherwise, we can come up with a discussion in my subsequent lectures about how to carry out these conversions. So we have discussed two operators, bitwise AND and bitwise OR, and they are similar to your AND and OR gates in working. And if in AND, if both the bits are high, that means both the bits are 1, then the resultant bit is 1, otherwise it's 0. In bitwise OR, even if one of the bits is 1, then the combination is 1. Okay, so that's all for these bitwise operators. In my next lecture, I'll be discussing the shift operators and the bitwise NOT operator, and I'll also discuss the levels at which they work and their associations. Thank you.